So solve 2 raised to power x plus x equals to 6. So no expansion method is allowed. We are still on Lambert W function. So this will be the second question we solve. So with no expansion method is allowed written, because I know people like shortcuts. So we are going to apply Lambert W function in solving this. Looking at this question, I know people can guess the answer here and they will guess correctly, but we are not to guess. So we have 2 raised to power x plus x equals to 6. Then we have the special function, that is seed multiplied by e raised to power seed. So when we apply Lambert W function to this canonical form, so we have the Lambert W function of seed multiplied by e raised to power Lambert W function of seed will give us seed, which is in canonical form. So there are two properties. We have e raised to power W of seed equals to W of seed divided equals to c divided by W of seed. So the first property. The other property is e raised to power minus W of seed equals to, we inverted this one, so this will be inverted too, divided by seed. This is the second property. So now coming to this, we are going to write this in this form by manipulation. Now the first step we are going to take is we are going to take x to the other side of the equation. So we have 2 raised to power x equals 6 minus x. So the next we are going to do, we are going to introduce logarithm function. So we are going to write this. This can be written as e raised to power x ln 2, which is equal to 6 minus x. Now when you look at this, so the power here is x ln 2 and the base here we have 6 minus x. We are going to make these two to be equal so that we can apply the Lambert W function, that is in the form of seed multiplied by e raised to power seed. Now how do we go about it? So when you look at this, so consider s, so you have to take s from 6, we are going to obtain this. But here we are having ln 2. It's a matter of multiplying ln 2 by it. Ln 2. That means what we need to multiply by this will now be, so we raise this to e raised to power 6 minus x ln 2 now. We are going to obtain, that means we have e raised to power 6 ln 2 then times e raised to power minus s ln 2. So because we are having negative s here, so that is why we need to apply this, that's why we need to manipulate this way. And before we can achieve this, we are going to rewrite this equation so that this will turn to negative power. So we have, so divide through both sides of the equation by this e raised to power s ln 2. We have 1 left here equals to 6 minus s multiplied by e raised to power minus s ln 2. So we are able to obtain the negative value. Now we can now multiply the both sides of the equation by e raised to power 6 ln 2. So that is we have 1 times e raised to power 6 ln 2 equals to 6 minus s then times e raised to power 6 ln 2 times e raised to power minus s ln 2. So here we have e raised to power 6 ln 2 equals to, and in this case now we have 6 minus s then times, so here we have common base e, then we have the power, we add it together because we are having multiplication. So that will be 6 ln 2 then minus, so plus and minus will give us minus s ln 2. So therefore we have 6 raised to power e raised to power 6 ln 2. So we have here equals to 6 minus s then multiplied by, we have e raised to power, so ln 2 is a common factor, we have 6 minus s then ln 2. Now to make this equals, we are going to multiply both sides once again by ln 2. So we have ln 2 times e raised to power 6 ln 2 equals to 6 minus s multiplied by ln 2 then e raised to power 6 minus s then ln 2. So the next we are going to do, we have the same thing. So that is, it is written in canonical form, c raised multiplied by e raised to power seed, where seed is 6 minus s ln 2. So when we take the Lambert W function on both sides, so we have Lambert W function of this e raised to power 6 ln 2 equals to the Lambert W function of 6 minus x ln 2 e raised to power 6 minus x, then ln 2. So the result obtained here will be 6 minus x, then ln 2. So here we have Lambert W function of ln 2 e raised to power 6 ln 2. Now, here we can divide both sides of the equation by ln 2 because we have to solve for x. When we divide by ln 2, we have 6 minus x equals to we have 1 over ln 2, then Lambert W function of ln 2 e raised to power 6 ln 2. Now we want to solve for x. Now we are going to, because of negative sign here, we bring x to this side. We have x equal to 6 minus this other side. This one is coming to the other side. So we turn this will turn to minus 1 over ln 2, the Lambert W function of ln 2, then multiplied by e raised to power. This can be written as ln 2 raised to power 6, then which equals to 6, then minus 1 over ln 2, then the Lambert W function of, now let's evaluate this. So e raised to power this will give us the result here, that is 2 raised to power 6. So we have ln 2 multiplied by e 2 raised to power 6. So we have x equals to 6 minus 1 over ln 2, then multiplied by Lambert W function of, this can be written as, so we have 2 raised to power 6 will be 64, then we have ln 2. Now let's evaluate this because it's a special function, and when you look at this, so is far as the range of x greater than 0. So there will be only one solution to this, that is along this blue graph. So because it's more than, the value of x is greater than 0, so there's only one real solution here, no other solution. So there's only one real solution. And how do we obtain that real solution here? So we need to evaluate, so the Lambert W function of 6 ln 2. So let's consider 64 ln 2 rather. Let's consider 64 ln 2. 64 ln 2 can be written as, so we can rewrite this as 64 can be written as 16 times 4, then ln 2, which can also be written as 16, then 4 will now serve as the power of 2 here. So that will be ln 2 raised to power 4, which is 16 ln 16. Now this 16 can be written as e raised to power ln 16. So then multiply by ln 16. So which is equal to ln 16, then e raised to power ln 16. So what we did here, we manipulated so that we can have the expression in canonical form in form of seed multiplied by e raised to power seed, so that we can take the Lambert W function on both sides. So this implies, so I want to simplify it here to save time. So therefore, when we take the Lambert W function of 64 ln 2, so because 64 ln 2 can also be written as ln 16 multiplied by e raised to power ln 16, and that is what we obtain when we simplify this. So which is also equals to the Lambert W function of ln 16 multiplied by e raised to power ln 16. So therefore we have, so when we simplify this further, so we have this will be seed. Then when we evaluate the Lambert W function, we are going to have seed, which is ln 16. So therefore this is ln 16, which can be written as ln 2 raised to power 4, which is equal to 4 ln 2. So therefore the result we obtained here will now be, we have x equals to 6 minus 1 over ln 2, then multiply by 4 ln 2. So this ln 2 will cancel out. So we have x equals to 6 minus 1 by 4 will give us 4. So therefore x equals to 2. Without inspection method, we are able to get the value of x to be 2. So thank you. Please like, comment and share. If you have any questions, you can drop in the comment section. Thank you.